of this. So there we go. Hopefully everyone can hear me good and well. So my name is Björn Skånberg. I work as support engineer for Know-How Solutions. And this is the second webinar in this series. It's called Maximize Your Development with KEIL ULINKpro. So last week I talked to you about how and what you need to start a project, which software packs you need to start. I showed you the real-time environment where you can add and remove components. I also showed you what templates are available and how you can use them. So today I will talk to you about debugging and trace with the ULINKpro. So I will show you what different trace and debug views are available. I will talk about the Coresight mail-only debug. So what you need to actually do debugging and trace. And then we will have a Q&A in the end. So for next week, I will talk about software packs, what it is, how you can create them and use them. I will show you some tips and tricks within Microvision, and I will also show you how to create your own configuration wizard in Microvision. So let's start to talk about Coresight. Coresight is basically the building blocks that you have within your MCU device. So this is the one that concerns debug and trace. So let's start by if you just have debug. So usually when you have debug, you have a standard JTAG connector, which is a 20-pin connector, or you have the little bit newer one called Cortex Debug connector. So usually the newer one, Cortex Debug connector, uses the 2-pin serial wire debug. So you have run, stop, and single step control. You can do breakpoints. You can read and write to registers and memory. And you can do flash download and verify. You might have the ITM and the DWT available as well. But since if you don't have any pins in your debug connector connected to these building blocks, then you can't use them, of course. So the next step is to use the serial wire viewer, which is basically you have the serial wire debug, the 2-pin interface, and then you have 1 pin of output for trace data, which is called serial wire output. So with this one, you get all the features you have with debug, but also you can do some PC sampling, event counters. You can show exception and interrupt with timing statistics. You can have some trace data from the ITM block. So you can do simple printf style debugging on ITM channel 0. I will show you this later on. And then the RTOS I'm using today, the KEIL RTX RTOS, uses channel 31 to send debug and trace messages. So then we have the instruction trace, which is done via the embedded trace macrocell, the ITM. So for this, you need the Cortex Debug plus ETM connector. So you have the same connector as before, and then you have 4 pins for trace. So this will give you extra analysis of execution history, code coverage, performance analysis, and application optimization. So this is the connectors I have on my target. So the one in the bottom is a standard JTAG, a little bit older. And then we have the Cortex half size for debug and debug with serial wire viewer. And then we have the Cortex Debug plus ETM, which has the full trace capabilities. So as you can see here on the signals, so pin 2 and 4 on the Cortex Debug is just for the debugging, and then you will add pin number 6 to do the serial wire viewer. And then to your right, you will see how the Cortex Debug plus ETM is looking. So here you can see that you have 4 pins for trace data and 1 for the trace clock. So this is needed for Cortex Debug with ETM. So before I go into the technical demonstration, just want to show you the contact we have. So for technical questions, please contact me, Björn Skånberg. And for sales question, please contact one of my co-workers. So let's go to the technical stuff here. So this is the project which I'm going to demo today to show you these features. And I have 3 threads in my RTX RTOS. We have 1 thread that controls the blinking of this LED. We have 1 thread that controls the ADC to measure it and to see if it's more than half its value. LED number 4 will be turned on. Otherwise, if it's less, it will be off. I have 1 thread that's controlling the screen, which just displays this text. I've also put an external interrupt on the wake up button, which will give me an interrupt and the printf debug message. So let's start. So this is the project. So the first thing we need to do is do the setting for the trace. So I will go into options for target. I will go into debug. I will choose the ULINKpro Cortex debugger, which is the one I'm using today. And you also need initiation file. Initiation file is basically a file that will tell the MCU to, now you should put out trace data, and you have 4 pins available to do this. So this is just some values that has been set at certain addresses. We will go into settings. Just these initiation files, it comes with the board support package. So this is not something you have to write yourself. This comes with the software packs. Let's go into settings. So I will use the serial wire. I will have 1 megahertz of trace clock, of debug clock. In trace, the core clock is 16 megahertz. I want to have trace enable. I can either use the serial wire output in Manchester mode, or I can use the trace port with 4 bits of data. I will also enable the ITM trace. I will do exception tracing to trace exceptions such as interrupts. Timestamps I must have enabled because to get the timing information. Also the ITM. The ITM I talked to you a little bit just before, and this is the 32 channels which you can use to send messages. So I will use channel 0 to send printf messages, and channel 31 to send for the RTX to send messages. Okay, so let's go. Let's download the code to the target. So we have the latest version. Let's go into debug. Let's close. Let's close this. And this. Okay. So first of all, I want to show you what you will get if you use only debug, no trace available. So obviously I have full ETM, but I will show you first what you can do when you just have debugging what you can do when you only have 1 pin of trace and what you can do when you have 4 pin of trace. So with only debugging, you have the run control. You can set breakpoints. So let's set breakpoint in the ADC thread. Let's set it here. So as you can see, this is dark gray while this is light gray. So it means that you can't set the breakpoint here because there is no code to set the breakpoint. So I will set my breakpoint. I can check in debug breakpoint or Control B to see which ones I have available. And if I run, my target will stop there. So there I can go step over, step out, and then I can go run to cursor line, which is basically, the cursor line is this line here, which will give you the disassembly view. So if I want to run to this line, I will just highlight it and then I will click run to cursor and I will go there. So this is what you can do when it comes to stepping and such things. So let's remove the breakpoint. I can have a look in the call stack to see the different values. I can have a look at certain variables which I want to look at, and I can also have a memory dump to see how my memory is looking. And I can also have a look on the peripherals. So the variable ADC val is the measurement from my ADC potentiometer, which I showed you in the beginning. So I can either do like this and have a look in the watch window, or I can go peripherals, can go system viewer. I will choose ADC, and it's ADC number 3 I'm using. So if I click run, so if I turn the potentiometer, you will see that the value here will be updated, and also the data register of ADC3 will be updated. So this is done in real time, like this. If I stop, I can also, if I want, edit values in the peripherals. Like if I want to put the 5 there instead, I can do it and just change it like this. You can also have a look in the core peripherals. So if you want to, just an easy example, have a look at the system tick timer. You can show it here, and then you will show the reload value and the current value. So this is also updated in real time, like this. So this is basically what you can do when it comes to if you just have the debug. So breakpoints, single stepping, watching variables, watching the memory, the call stack, and having a look in the peripheral. So now I'm going to show you what you can do if you have 1 pin of trace, if you have the serial wire output. So we can have the printf, which is using the ITM channel 0. So as you can see here, there's already been a few printfs made. And we can have the logical analyzer. We have it here. So we can add, now it has already been added. Let's see, let's just remove it and do it again. So you can add the ADC value to this by right-clicking, either when it's in watch window or when it's in the text editor. Add value to either watch, to add it to the watch window, the memory window, or logical analyzer. And then I just need to do some setup, because this is a 12-bit ADC, so max value will be FFF. So I will do like this. I will click close. So if I run, you will see that the value is updated. You will also see that if I turn the potentiometer, value will go up and then value will go down. And you will see that the printf is updated as well. Let's see, we can have a look on how the kernel, the RTX, is doing. So if we go into debug, OS support, we can have a look in the system and thread viewer. So here you see what threads I have created, what state they are in, stack usage, certain delay. I can also see how the threads are running together, so to say. So if I click run, you will see that all the threads will come up like this. And if I click the interrupt, you will see that there will be a new line down here, and also that it's the printf message will be shown. If I click stop, so here you can see in time how it's actually looking. So you can have a look and see the external interrupt was interrupting the GUI thread, and you can have, since we have cursor available, you can see, okay, it took 34, as you can see down in the gray, the D is 36 microseconds, so you know how long it took for the interrupt to execute. And then we can see something about this in this window. I can also have a statistical view of the trace exceptions that has been conducted. So if I go trace exceptions, you will see what has been executed. So as you can see, these numbers are quite large. This is because I've had trace from the beginning. So it was started when I started the debug session, but I'm showing it to you now, so this is why it's quite big value. So you will see what has been done, like this. So this is more or less what you can see when you have the serial wire viewer and you have one pin off trace. So let's have a look what you can see if you have the full 4-pin trace. So you can have a look at the code coverage. So if I click code coverage, if I click update, like this, so you will see you can either sort on all modules, or you can sort it on a certain module. Like if we want to have a look at some application code, like the GUI single thread. So here we can see that the thread has been 100% executed, and the initiation of the thread 92% was executed. So here you see, because it's basically if the thread creates and it's given a number, so if this number was not correct, it will return -1, and otherwise it will return 0. So this is also that you can see that this color here is green, which means the source code has been executed, and gray means it hasn't been executed. You can also see this in this assembly view. So you have the gray ones, the green ones, and then blue means conditional jump. So it has tested the condition, but the condition was never taken. And also, as you can see, there are a number here, which is basically how many times has we run this line of code. Or you can show it as a number, or you can hover over it and get time and then average time, or you can just show it as the time, like this. So you have total time, number of calls, and then average. So it's a little bit of what you can see with this. Next, yeah. So next we have the performance analyzer, and this is giving you what function, where the CPU spends most of its time. So this is updated in real time as well, sorted on what's taking the most time. So you can either go modules or you can show functions like this. So as you can see, there is a function that writes to the GUI that's taking up the most time, which is not very surprising. So this is a quite nice way of showing what function is taking most time. Last but not least, you are able to see the trace data with ITM, and we also have the trace navigation. So here you can watch all. So if you want to see both what source line it was and what function, and you see the assembly instructions, or if you just choose to see it as the high level code, this is possible as well. So here, if you want to smoothly go between the different lines, you can use the trace navigation, which will take you back and forth in the different trace data. You are also able to search if you're looking for LCD, let's say. You're also available to search within your trace buffer, so to say. So this is what you can do with the ETM. You have the trace data, you have the performance analyzer, and you have the code coverage. So this is the updated. So what you need to check when you want to see what you can do is first what Coresight you have available, what building blocks. So let's say you have ETM available, then it's very good. And then you have to check with your hardware department if they have taken those pins to the debug connector or they have done something else with it. So this was about it for me. I will see if I can manage to unmute you all so we can have questions. Hold on. There we go. So I will start recording now. So